If you've made it this far through, here's where the payoff is. All right. So, a coherent system of units as a system of units of measurement used to express physical quantities that are defined in such way that the equations relating to numerical values expressed in the units of the system have exactly the same form, including numerical factors as the corresponding equations directly relating the qualities. It is a system in which every quantity has a unique unit or one that does not use conversion factors. Okay. At least the question, what are conversion factors? Conversions of units. Okay. Conversion of units is the conversion of the unit of measurement in which a quantity is expressed, typically through a multiplicative, aka you probably like multiply or divide something, conversion factor that changes the unit without changing the quantity. Okay. This is often loosely taken to include replacement of a quantity with a corresponding quantity that describes the same physical property. Okay. Unit conversion is often easier within a metric system, such as SI, than others due to the system's coherence and its metric prefixes that act as a power of 10 multiplier. Oh, that makes things a lot easier. If we could have base 10 or something like that, God, that would make our lives a lot easier. Wouldn't that be neat? We go back to coherence. Okay. And then we have over here, we'll just touch this, a derived unit, that for which a given system of quantities and for a chosen set of base units is the product of powers of base units with a proportionality factor being 1, aka length divided by time is speed. If it happens to be Planck length divided by Planck time, we're pretty much going to get C. Okay. All right. So those are words. That's Wikipedia. Don't necessarily believe this. Feel free to trust if you want, but please, good God, verify. All right, here's the thing. Dimension-related coherence. Okay, those are a bunch of words. Well, this is what really got me into this conversation is when Kevin was out here and Thad had posted that video. Okay, so here we go. Let me hydrate a bit. All right. Each variant of the metric system has a degree of coherence, the various derived units being directly related to the base units without the need of intermediate conversion factors. An additional criterion is that, for example, in a coherent system the units of force, energy, and power be chosen so that the equations force F equals mass M times acceleration A, and energy big E equals force big F times distance little d, as well as power big B equals energy big E divided by time small t, hold without the introduction of constant factors. Once a set of coherent units has been defined, other relationships in physics that use those units will automatically be true. Einstein's mass-energy equation, E equals mc squared, does not require extraneous constants when expressed in coherent units. Oh, that's very interesting. Huh. So let's go through that, and then we can start to wrap up. Okay. So what do we have here? Let's go back. So force equals mass times acceleration. So let's do this. So force equals, let's just use Planck units. Planck mass, and then acceleration is length divided by time squared. So let's just do this. So then we're just going to do this. Planck length divided by Planck time squared. Throw this back in here. Okay. So what we got? We've got, finish putting our mass term in it. All right. So we've got mass, and this should be acceleration. If I take the extra bracket out. Okay. So this is force. All right. So we got the Planck force there. So that's a unit of force. Okay. So the other thing that we need is we need energy. So that's force times distance. So if distance, that means we need a length. So that means we take this guy out. We'll throw some protective brackets over there. Now we're going to multiply it by distance. Okay. So for those of you that might be more physically inclined, you may notice we've got a mass and we've got a length divided by time squared. If we add another time in there, we've got, oh wait, that ends up being c squared. Oh, so force times distance equals energy. Oh, looky, Planck energy. We're in the right dimensions. So what was the last thing we needed? We need power. God, the memes still live within home improvement. Power. So that's just energy, what we got there, and then we divide out a unit of time. Okay. So if we've got all this, so let's see if we can get an intuition for what's going to go on here, because it took me a dang long time because I don't have a formal physics training background. Okay. So we've got energy. So if we're going to divide by time, that means time goes into the denominator. So right now we have 2 of them in the denominator because that's negative. So that means it goes down below. So if we're going to divide out, that means it's going to go to time to the -3 because we're going to have 3 in there. So that should give us power. So let's do it. Let's divide by the Planck time. Let's see what we got. Oh, look, we got the Planck power. Yep, we're in the dimensions of power. So the whole point of this is once you have a coherent system of units and they can reference each other and you can go back and forth. Basically, once you get F equals ma, that force equals mass times acceleration, if you have coherent units, you should be able to multiply that force times distance to get energy, as well as take that energy and then divide it by time to get power. And at this point, you now have a coherent system of units.